last video. This is the last page of the Unit 9 review. This is solving cube and cube roots. And remember, you can always check these in the graphing calculator as well. I'm going to show you algebraically. We have isolated our cube root, so we are ready to cube both sides. So 4 cubed is, let's see, 64. And then that gets rid of it. So we're at 32a. And now we need to divide out that coefficient of 32. What you do to one side, you do to the other. 64 divided by 32 is 2. So a is 2. Now, when you solve by raising both sides to a power, that's when you could possibly create the extraneous solutions. So you just want to double check. If I plug that 2 back in, 32 times 2 is 64. The cube root of 64 is indeed 4. So this one checks out. So you can check it that way. Or in the graphing calculator, you can do y equals the left, y equals the right, and look for where the graphs intersect. You're looking for the x value where the graphs intersect. You would be typing in x instead of a. Doesn't matter what variable is used here, just always use x. All right, here we've got some movement to do before we're ready to cube both sides. So I'm going to add that 7 over. Gets us to -2. Then I'm going to divide the coefficient over. Now I've isolated the rational exponent, and negative divided by negative is positive. That is 1/2. Now I am ready to cube both sides, because remember, the opposite of a 1/3 power is the third power. And I say the opposite, the operation that will reduce that to a 1. Because remember, a 1/3 power is the same thing as a cube root. So the opposite is to cube. So we end up with x equals, and then 1/2 cubed. So the same thing I was saying in the previous video, where was it? That when you take the root of a fraction, you can take the root of the numerator and denominator separately. Same thing when you raise a fraction to a power. You can raise the numerator and denominator separately. So 1 cubed is still 1. So my numerator is still 1. And then 2 cubed is 8. So that becomes 1/8. And then you could plug that back into the original to check. If I plugged in 1/8, I would have to do the cube root first. The cube root of 1/8 would be 1/2. -4 times half would be -2. -7 minus 2 would be -9. So it does work out. All right, here, this is a different type of solving where we had to do factoring by grouping, because this is in standard form, not vertex form, and you have 4 terms. So you put the first 2 terms together in the first group and the last 2 terms together for your second group. And then we're looking for the GCF in each group. So GCF there is x squared. I can divide both of those by x squared, and that would leave me with x minus 5. In the second group, my GCF is 3. And I divide out the 3, and that leaves me with x minus 5 as well. That's what we want. Those leftovers should be the same. That means that that is a factor. And then you bring together the GCFs you pull out as your other factor. Remember, this is all still equal to 0, and we split and solve. So over here, I would add the 5, so that would be x equals 5. Over here, I would subtract the 3. So I have x squared equals -3. And then I try to solve it by taking the square root. That's not possible. I cannot square root a negative. So there's no solution from that side. So the only solution I get is 5. And then I could go and plug that in and verify that it works. All right, my first group here, my GCF is x squared. It's going to leave me with x plus 2. In my second group here, oh, tricky. It's not set equal to 0 yet, so that 18's on the other side. So to move it over here, I would have to subtract it. So it's going to become minus 18 over here, and then I'll be left with a 0 on the right. So that'll be negative 9x minus 18. So the GCF there is going to be negative 9. And I would be left with x plus 2. Good sign. Leftovers are the same, so that's a factor. And then you bring the GCFs together as your other factor. Split and solve. Subtract the 2 over, so I get negative 2. Add the 9 over, so I have x squared equals positive 9, so I can take the square root here. Now what I need to remember, since I'm allowed to take the square root, is to put the plus minus in front. When you take the square root, any even root as part of solving, don't forget your plus and minus. So positive 3 and negative 3 and negative 2. So we had 3 solutions for that one. All right, 17. We have a 1/3 power, and it's all this side. So it's already isolated. So I'm ready to just cube both sides to get rid of that. Make sure you put parentheses. So that's going to get rid of that. And so now I've just got x cubed plus 2x squared minus 10x minus 28 equals, and then negative 2 cubed would be negative 8. So I need to move that negative 8 over by adding 8. So I'm going to add 8 to this side to get this side to be 0. So that will be, well, this stays the same. That would just be minus 20. Now it's set up for us to do our factor by grouping. So the first two, the grouping, the GCF is x squared. That would leave you with x plus 2. And the second group is negative 10x minus 20. So we could take out a negative 10 to be left with x plus 2. Again, good sign that our leftovers are the same. So x plus 2 is a factor, x squared minus 10 is a factor. If I set x plus 2 equal to 0 and solve, I get x is negative 2. Over here, I can see right away. I'm going to have to add the 10 over. And then I go to take the square root. Don't forget the plus minus. So I get positive and negative square root of 10, which I can't simplify. So that's as far as I can take it. Ooh, this one is fun. You know what? You are not going to have one like this in level. This is more of an honors level question, so I'm going to tell y'all you can skip it. The reason that one would be more honors level is because you have cube root on both sides, so you would think, well, can't I just cube both sides? And yes, technically you can, but there's also a coefficient that would end up being cubed, and it just gets more complex, and there's a lot of movement there that you're not going to be required to do on the test. 19 and 20 are more our pace, where both sides are raised to the 1/3 power, and there's nothing outside them. So I don't have to worry about that extra stuff. So I'm going to cube both sides to get rid of the 1/3 power, and I'm left with x plus 1 equals 3x plus 5. Now it's a basic algebra problem. I've got x's on both sides. I need to get them to the same side. And then the constants would have to go to the other side. So I end up with 2x and negative 4. Now I'm going to get rid of the coefficient 2. And I end up with negative 2 equals x. Now I did raise both sides to a power at the very beginning to solve, so that is one that I would want to go and double check my solution. So negative 2 plus 1 would be negative 1. Negative 2 times 3 would be negative 6 plus 5 would be negative 1. So you end up with the same thing on both sides. All right, a similar strategy in this last one. They're both cubed, so we are cube rooting both sides to eliminate that. So I'm left with x plus 1 equals x squared plus x. All right, so this is a little more complex because we have more than one x term. So I'm going to get everything to one side set equal to 0. So I'm going to subtract the x over, and I'm going to subtract the 1 over because I want it to equal 0. So I end up with x squared. Hey, look at that. X minus x, that reduces. It's 0 anyway. And I just have minus 1. Now it's just a basic one that I can solve. So I'm going to add that 1 back over to the other side and take the square root. And don't forget the plus or minus. So positive and negative 1. Okay, that is it. That is the end of your review. If you need other parts, this was all split up. I think it ended up being 5 videos for y'all.